Okay, grade 11s, welcome back. In this video, I'm going to show you how to do an exponential regression. Now, basically all that means is that we're going to take the data here in the table, which we have already entered, and we're going to have the graphing calculator give us the exponential equation that best fits our data. Now, it's important that we have entered the data at this point. It's also important that the diagnostics are on. If either of those things hasn't happened, it's going to make the process very difficult. So I can see here that my diagnostics are on, and as long as you haven't turned off the calculator, they should be. If you need to clear the RAM or turn on the diagnostics, make sure you go back to video 1. However, if you have already entered the data, please don't clear the RAM. That will delete everything that you've done and you'll have to start over. So to make sure that the data is there, just click on Stat, and you'll see Edit, hit Enter, and I can see my data, so I know I'm good to go. And if you can't see your data, revisit the second video and just make sure to enter your data and then come back. Okay, so I'm going to assume that everyone has the data entered, and if you don't, again, make sure you go back and do that. So this video, the first part, actually running the regression, will be fairly quick, and then the rest of the video, we're going to actually look at each of the numbers that were given and talk about what those represent. So the first thing that we are going to do is we are going to have the calculator run a regression analysis to see whether or not this data can be fit with an exponential model. So to do that, we first start, again, we hit the Stat button. But this time, instead of editing the stats that are there, we want to perform some calculations. So we click over, and we're on the Calculate menu, and we're going to scroll down until we get to the exponential regression. So you'll see this is linear, quadratic, cubic, quartic, we need to know what those things are. Linear, again, a different type of linear, and here we are, exponential. And really the shortcut here, if you want to write this down, is you can just push 0. So you can see here that you're ready to go. The common mistake here is that people are going to hit enter, and that really won't get them anything at all. Because the computer needs to know, you want to perform an exponential regression, well, what variables do you want to do that on? So you remember back to the table, and at the top of the table in the calculator, it said L1 and L2. So we want to perform this regression with an independent variable that's L1 and a dependent variable that is L2. So to do this, we hit the second button, and here we can see L1, so we hit L1. And then comma, because we want to separate the two variables, so we want to do a regression on L1, comma, hit the second, L2, another comma, and now we got to tell it what do we want it to call this function. Well, we want it to call the function y1. We could have y1, 2, 3, 4, 5. Really, that's 5 different functions. And to set the function, we hit bars. We scroll over to here to the y bars, it's basically the different y variables, and we're going to make a function. So we hit enter, and we want y1. So we hit enter again. And here we are ready to go. Basically, we hit enter one more time, and it runs it for us, and it gives us a whole bunch of output, which we're going to spend the rest of the video taking a look at. I just want to remind you that if you haven't been writing down on the cheat sheet how you do each of these things, please go back in the video and make sure you do that. When the test comes and you're given a problem like this, you're going to be able to need to do it without any help from me. So once again, go back in the video and make sure you are writing down the steps as we go. So now we hit enter. You can see it's thinking up in the right corner. It's done now, and here we go. So this is the output you will see, exponential regression. The first thing here tells us that this is an exponential function in the form y equals a times b to the exponent x. Our a value is 20.448. Our b value is 1.41. I'd round this to a 5 because of that 8. And you can ignore the bottom value, but the r squared value is 0.977, and this is an important piece as well. So I'm going to just capture this to my screen over here, and then we're going to talk about what all of these things mean so that we can have a better idea of what our equation tells us. Okay, so what I've done here is I've just brought the function, the screen into my program so that I can sort of write on it. Okay, so again, this tells us that we found an exponential function, and this piece here tells us what the function looks like. And basically this tells us that it's y equals a times b to the exponent x. And you should remember from the last few days that this first value, the a value, is the initial value, and the b value is the ratio that the values go up by each time. So here we can see that our a value is, pardon me, I'm going to make that a highlighter instead. There we go. Our a value is 20.4, and if I were to round that to 2 decimal places, the 8 would bump that up. So what I would have here is that my a value is 20.45. And again, this is in millions, so this means initially in the year 2000, according to the model, we had about 20.45 million. Now you can see that's a little bit different. When I say a little, it's 4 million. It's a fairly large difference between the original value. But again, that's because this function is doing the best job it can at approximating the relationship. So now the next thing that we're going to do is we're going to look at the b value, and we can see that here. And b equals 1 point, and I'm just going to round that to 2 decimal places, so 1.41. Now what this tells us, first of all, b is greater than 1, so we know that it's increasing. And of course, if we look back at the graph, we can see that it is certainly increasing. And the 4.1, so the 1.41 tells us that it is actually increasing on average by 41% per year. And that's a very key thing to know. So this tells us an average increase of 41% per year. Now, if we were to go ahead and actually write this equation, it would be y equals 20.45 times 1.41 to the exponent. Okay, so now that we have this equation, it's also worth mentioning just what each of these variables represents. So first of all, the y value is our dependent variable. So in this case, the y value represents the subscriptions in millions, which in this case is really just the number of people with cell phone subscriptions in Africa. And the independent variable, or the x value, is the year, or the years since 2000. And this is very important. If we put in 0 for x here, that represents the year 2000. And obviously that's a good thing, because if we put in the year 0, we don't want that to be 2,000 years ago, because chances are the number of cell phones 2,000 years ago was pretty darn low. So what we can do using this equation now is we can actually make estimates about the number of cell phones in the past, and we can also take this into the future. And to do this, all we have to do is to sub in different values for x. So on the next page, I'm going to have the equation, and we're just going to punch in a couple of different values and see what comes out. Okay, so why don't we go ahead and we'll just set a couple of different values that we're going to investigate here. So let's look at the year 2020, and let's look at the year 1980. Okay, so in the year 2020, well, we need to put that in terms of 2000. So obviously in 2020, our x value is going to be 20. It's 20 years after. Now, here's where things get interesting and can get a little bit confusing. In 1980, well, that's 20 years before the year 2000. So in 1980, we actually have that x equals negative 20. So that means we're going to have to substitute a negative x value into our equation. The shortcut to all of this is whatever year you're looking at. So let's say we're doing 2020. You subtract the initial value, and you get 20. We're doing 1980. You subtract the initial value, and you get negative 20. So again, whatever year you're interested in, you subtract the original, and that will tell you what your x value is going to be. So I'm just going to go ahead and erase that. And you might want to take a note somewhere on there about these years going forward and backward. And then here I'm just going to put a number of cell phones in millions, and then I'll calculate them. And I encourage you to use a calculator to calculate them as well. In fact, I suggest that you do it before I do by taking the 20, plugging it in there, and then taking the negative 20 and plugging it in there. And just ensure that you get the same values that I get. Okay, so I ran the positive 20 in, and I got 19,727.66 million. So that is, well, that would be 19 billion, or almost 20 billion cell phones in Africa in 20 years. So obviously we can see that there's a bit of a problem there because there aren't even that many people in the world. There's not even close to that many people in the world. So the problem with this model that we can see, I'm just going to draw it here, is that an exponential model, as we've seen in class, takes off really quickly. So basically what's going to happen here, if we go back and take a look, is it's going to come up like this, and then what's going to happen is the model is just going to kind of launch off there, and it's not going to do a very good job of predicting far into the future. So I'm going to pause it and I'm going to plug in the values for negative 20, and again, I encourage you to try this first. Okay, so when I did this, I got 0, pardon me. Okay, so I got 0.021 million. So if we multiply that by 6, what we would end up with, sorry, I'm going to multiply that by a million. I just meant the decimal place to the right. We would have just over 2,000 cell phones back in 1980. The interesting thing about this is that although that value kind of makes sense, we know that back in 1980, there probably weren't more than a couple of thousand cell phones on the continent of Africa because there really weren't any cell phones around. But essentially, this is how you would use one of these equations to predict values in the future with positive x values, and in the past with negative x values. And now, please ensure that you have filled in your cheat sheet for all 3 videos, and if you haven't, go back and complete them before moving on to the rest of the exercise.